population of cancer cells are actively growing. So here, you do the Pearson test, you can see that there is a negative correlation with an R value of negative 0.55. And the p-value is less than 0.001, that these two quantitative values are correlated. And this correlation is an inverse correlation. So as one increase, the other one go down. So what if you don't have a continuous variable, you have ordinal variables, or you have a skewed continuous variable? If you have, in this situation, you can use a different correlation test that's called Spearman rank order. It's used to examine the relationship between the two ordinal variables and two skewed continuous variables. It is the non-parametric equivalent of the Pearson correlation. Time to event analysis. Very often we refer to it as the survival analysis. When we deal with animals or we deal with humans, or when we look at carcinogenesis, or we can, when we look at the effectiveness of treatment in terms of how long the mice or the animal or the patient can survive, we use this method called Kaplan-Meier method. Kaplan-Meier method basically it's a modeling that models the time to event, the risk or the probability of an event is happening given the probability of what has already occurred. So after the survival curves are plotted using the Kaplan-Meier method, very often you would be able to tell that there is a difference or there is not a difference. Because, of course, the number of patients, the size of the sample make a difference in terms of whether the difference in the curves are significant or not. In order to determine whether the curves are significantly different or not, there are several different tests to use to compare the Kaplan-Meier curves. One of the favorite or most frequently used tests is called log rank test. It's used to compare the survival curves. Another very popular method to compare survival is to use a different theorem, proportional hazards. The Cox proportional hazards method can also compare survival, but the Cox proportional hazards can be done in the univariate analysis, okay, using one factor. And the big advantage of the Cox modeling is to use regression to analyze multiple covariates. So the multivariate analysis using Cox regression model is a very powerful tool to control for many potential factors that can influence survival or can influence a time to event analysis outcome. So univariate analysis usually refers to one predictive variable or one outcome variable. For example, we ask the question, is diabetes a predictor of cancer? We only have one outcome variable, cancer, and one predictive variable, diabetes. What if we ask the question in a more sophisticated way? Because cancer can be influenced by many things: exposure to carcinogens, smoking status, age, gender, etc. So we need to control for the influence of different factors. After multiple potential factors are controlled, is or does diabetes remain as a significant factor? Okay, if we ask the question in that way, we would need to do multivariate analysis. The multivariate analysis refers to more than one predictor variable and more than one outcome variable. But usually, we keep the outcome variable as one, and we construct a model with multiple predictor variables. So, in other words, you're framing the question in a different way. The asker, after adjusting for age, gender, smoking status, etc., is diabetes a predictor of cancer? So that is the question. You're asking the question in a more sophisticated way. Then with Cox regression models, what are the factors that you want to test in the model? You need to justify why you include the variable that you included and exclude other variables that can potentially affect the outcome. You need to design the statistical model a priori, ahead of time. But you're not just playing with the computer, pick and choose so that you get the p-value of less than 0.05. Okay? You don't do that. Because that is probably what you're doing with what's called a stepwise regression. Okay. Stepwise regression is okay for exploration, but the final model that you pick, you must have justification. Why you include certain variables and why you exclude certain variables. And many journals do not accept stepwise regression for publication. So here is an example of the Cox regression model of survival. So for example, in this paper here, that we're looking at cancer survival of prostate cancer patients. Black race. Why did I include black race as a factor? Because African Americans are known to have more aggressive prostate cancer and have a higher mortality. So therefore, black race is a significant factor that can influence the outcome of survival, so it needs to be included. Age at the time of the diagnosis of survival. Okay. Here, we're looking at overall survival. The older you are, the more likely you're going to die. So therefore, age when you're at which you have the diagnosis needs to be included. The Gleason grade of the cancer, the pathology, how aggressive the cancer is on histology, the grading of that need to be controlled for, accounted for. If you have more aggressive cancer, high Gleason grade cancer, you are more likely to die. Stage of the cancer. If you have stage 4 cancer right at the time, at the very start, when you get diagnosed, of course you're going to live shorter compared with the people that were diagnosed at an earlier stage. Okay. These are the factors that are well known to affect the survival of the cancer. That justifies the inclusion of these factors in the model. Okay. Now comes to the factors that you want to know, the test, that you hypothesize that may influence the survival. Here, we include whether the patient's fat or not, and the diabetic drugs that the patients are taking and see which one of these drugs may have association with the survival. So in other words, in this model, my question is whether any of these drugs or the obesity status are significant prognostic factors after controlling for these known factors that would affect the prognosis of these cancer patients. So in constructing these models, you have to have a question. What is your hypothesis? What is the question that you're asking? You don't do stepwise regression and just put this data set and let the computer crunch the numbers and come up with, oh, this is significant, this is significant. When you put them together, it's significant. What is your question? What are you trying to answer? What are you trying to control? That's why that kind of stepwise regression is bullshit. So linear regression. Now, moving away from survival analysis. Linear regression is used to analyze or examine how one or more predictive covariates can be used to predict a continuous variable. For example, do age or comorbidity or the mean blood pressure or the procalcitonin level, is one of the hormone levels, can predict how long the patient is going to stay in the hospital after admission to the hospital for sepsis. So the length of stay in the hospital is a continuous variable. And in order to analyze how these factors contribute to the length of the stay, this linear regression would be able to identify which one is a significant predictive factor. It's a multivariate analysis, analyze the association between these factors, and it would work